Hello, everyone. In this video, we want to go ahead and look at example 9 for review 3. We're going to find the open intervals where the functions are concave up and concave down. Find any inflection points. So concavity is the second derivative. So on A here we have f of x equals f of x is equal to 4x cubed plus 24x squared plus 6x plus 1. We want to go ahead and find the first derivative. So the first derivative is 12x squared plus 48x plus 6. So the second derivative here is 24x plus 48. Good. Once you've found the second derivative, set it equal to 0 and go from there. So we have 24x plus 48 is equal to 0. Subtract the 48, divide by 24. So x equals -2 is a possible inflection point. So we need to go ahead and create a number line. The -2 is the possible inflection point, which means we need points to the left and right of -2. Let's just say maybe -4 and 0, something like that. Now, if you take those and plug them into the second derivative, and again, this is the second derivative that we're plugging them into. So plug in -4, it's going to give me -96 plus 48. That's a negative. So that's negative there, which means it's concave down. And then the positive, plug in 0, that's 0 plus 48. That will give me a positive. That's going to be up in that region, concave up. So it's concave down in the region from -infinity to -2, and it's concave up in the region from -2 to infinity. And we also want to know, are there any inflection points? And -2 does produce an inflection point, so we need to figure out what is f of -2. Well, if we go to the calculator, I don't need to type in the original function here, just 4 times -2 cubed plus 24 times -2 squared plus 6 times -2 plus 1. There we go. Notice that it is, in fact, 53. So there we go. So there is an inflection point, and it occurs at the coordinate of -2, 53. Outstanding. That is 9A there. Next, let's look at 9B. So 9B is f of x equals 6 divided by x plus 6. Now, if you notice, the domain here is that x is not equal to -6 because x plus 6 is not equal to 0. Now, we can use the quotient rule here, but I'm actually going to rewrite f of x as 6 times x plus 6 to the -1 power. That makes it easier to find the derivative here because now I don't have to use the quotient rule. I can just use the power rule with the chain rule. So the first derivative then would be -6 and then x plus 6 to the -2 power, and then times the derivative of x plus 6, which is 1, so I don't need to deal with it. So this is why I wanted to go ahead and use the power rule here, or I wanted to rewrite it so I can use the power rule. So the second derivative then is the derivative of the first derivative, which means I can use the power rule again. -2 times -6 is positive 12 times x plus 6 to the -3 power. Good. Now, if I rewrite this, that gives me that 12 divided by x plus 6 to the +3 power is the second derivative. Good. Now I can find possible inflection points from either the numerator or denominator equaling 0. Well, 12 equals 0 doesn't produce any possible inflection points. But then we have x plus 3 cubed equaling 0, which of course means x plus 6 equals 0. And that tells you that x equals negative 6. But here's the thing. X equals negative 6 is not in the domain. So it can't be an inflection point. But it is still an important number. So we need to go ahead and look at our number line here. Negative 6 is an important number, and it's not an inflection point no matter if we change concavity on each side. And it's possible. But in this case, we're going to go ahead and look at it. So negative 6 to the left of negative 6, say maybe negative 8. And to the right, maybe negative 4 or even 0. It doesn't really matter what you use. And then go plug these into the second derivative. Negative 8 plus 6 is negative 2. Cubed is negative 8. So that's a negative there. So produce a negative, so it's concave down there. And then negative 4 plus 6 is 2. 2 cubed is 8. 12 over 8 is a positive. So it's concave up. So we have concave up from negative 6 to infinity. And we have concave down from negative infinity to negative 6. And also, as we said before, there is no inflection point, even though the concavity changes to the left and right of negative 6. If you plugged in negative 6 into the function, that gives you an undefined value. So therefore, there are no inflection points. All right, there you go. That is question 9 on exam 3 review. Have fun.